Look up tonight. Now imagine the moon just isn't there anymore. Not eclipsed, not clouded over, gone instantly without warning. Within hours, oceans on the side of the planet closest to where it used to be would drop by more than half a meter, and every coastline on Earth would start behaving in ways nobody alive has ever seen. Here's the premise, so the physics stays honest. The moon vanishes completely, instantly, with no explosion, no debris, no warning. Earth keeps orbiting the sun exactly as before. Nothing else about the solar system changes. We're isolating one variable, the moon's gravity, and watching what actually depends on it. The most immediate effect is tidal. The moon's gravity is the main driver of ocean tides, pulling water into a bulge that follows it around the planet. Remove the moon, and that bulge doesn't just shrink, it mostly disappears. The sun still raises a much weaker tide on its own, so tides don't vanish completely, but they drop to roughly a third of their former range almost overnight. For coastal ecosystems that depend on twice-daily tidal cycling, mudflats, mangroves, tidal marshes, thousands of species timed to that rhythm, the change would be sudden and severe, not gradual. Next comes something less obvious but more dangerous long-term: Earth's tilt. Right now, Earth spins on an axis tilted about 23.5 degrees, and that tilt is remarkably stable, wobbling only slightly over thousands of years. The moon is the reason. Its gravity acts like a stabilizing hand, keeping our tilt locked in a narrow range. Without it, Earth's axis would still drift now, but very slowly at first, nothing dramatic in year one. The real danger is on geological timescales. Models suggest that over millions of years, the tilt could swing chaotically, anywhere from nearly 0 degrees to as much as 85. The kind of instability actually seen on Mars, which has no large moon of its own to stabilize it. What does a wildly shifting tilt actually mean for the planet? Seasons, as we know them, are a direct product of that 23.5-degree lean. A near-zero tilt would erase seasons almost entirely. Endless, unchanging climate band by latitude. A tilt pushed toward 80 degrees would do the opposite. Brutal, extreme seasonal swings, with some regions plunged into months of permanent darkness or scorching, continuous sunlight. Neither extreme resembles the stable, moderate seasonal pattern that agriculture, ecosystems, and human civilization were built around over the last 10,000 years. Then there's the length of the day itself. Tidal friction from the moon has been gradually slowing Earth's rotation for billions of years. That's why, 400 million years ago, a day was only about 22 hours long. Take the moon away, and that slow braking mechanism switches off. Earth's rotation would stay locked in at whatever 24-hour rate it happened to be at the moment the moon disappeared, no longer gradually lengthening. It sounds like a minor footnote, but it means every other consequence. The tidal collapse, the eventual tilt instability, unfolds against a planet that never had the chance to keep the deep, slow motion clock the moon had been running for it since Earth's earliest history. Darkness changes too, in a way easy to underestimate until you actually picture it. A full moon is the brightest natural object in the night sky by far. Nocturnal predators, migratory animals, and countless species that navigate or hunt by moonlight would lose that light source completely, plunging clear nights into a darkness closer to what deep wilderness away from any city looks like on a moonless night today, just permanently. For nocturnal ecosystems built around that light cycle, it's not a subtle shift. There's also the question of impacts. The moon's gravity helps sweep up some wandering debris that might otherwise cross Earth's path, and its heavily cratered surface is visible proof of just how much material has been absorbed over billions of years. A record Earth's own weather and plate tectonics erase, but the moon simply keeps. That doesn't make the moon a perfect shield. Most of that protection is a side effect of the moon and Earth sharing similar orbits, not the moon actively blocking incoming objects. But losing it does remove one gravitational influence that has, over deep time, nudged some nearby debris out of Earth's way, marginally raising the odds of an eventual close call. And there's a cultural, almost psychological loss that doesn't show up in any tide table. Tens of thousands of years of mythology, calendars, poetry, and navigation were built around a moon that was always there, waxing and waning on a predictable 29-day rhythm. Lose it, and you lose a reference point every human culture in history has shared without exception, since before written language existed. Put the pieces together and a real pattern emerges. The damage isn't evenly distributed across timescales. Tides collapse almost immediately, that's an hours today story. Rotation stops slowing, an instant permanent change to the deep clock of the planet. But the tilt instability, the seasonal chaos, the true climate disruption, that's a story that unfolds over hundreds of thousands to millions of years, not overnight. Early humans, if they were still here, wouldn't feel civilization collapse in year one. They'd inherit a planet whose long-term stability had quietly been switched off, with the consequences arriving on a timescale longer than our entire recorded history, which is really the deeper point of this thought experiment. We don't think of the moon as doing anything. It just hangs there, changing shape every month, mostly ignored. But it's been quietly regulating our tides, stabilizing our axis, and slowing our spin for over 4 billion years, the whole time civilization assumed the sky was simply a backdrop. Take away one dead, airless rock a 250,000 miles away, and you don't just lose a pretty light in the night sky. You lose one of the quiet reasons Earth has stayed as livable and as stable as it has for all of human history.